Hi, welcome to the exercise of lecture 4 in chemistry. We will start with exercise number 1 that basically asks us give the structures of the carbon compound and amine which will be used to prepare each of these following imines or enemies. We have this. Okay, and this should come, remember that we break this carbon double bond nitrogen, and here we have the aldehyde, the ketone, plus the primary amine. In the second case, we have an enamine. Okay, and we do exactly the same. We cut this part. Here we will put the carbon group. That means that will be this. And in this case, because it's an enamine, will be the secondary amine. Next case. Okay, we have this imine, and we do exactly the same that we did in the first example. We cut from this part. We have here the aldehyde in this case, where we have the carbon double bond nitrogen, we put an oxygen, and where we have the nitrogen double bond carbon, we put two hydrogens. That means that will be okay, and the last one. We have this example, and we do exactly the same. Carbon double bond nitrogen, cut it, and we will get this aldehyde, because when we put a carbon double bond nitrogen, we put an oxygen, plus the primary amine. Okay, basically the trick is we break the carbon nitrogen bond. Where we have the carbon double bond nitrogen, we put an oxygen. Where we have the nitrogen double bond carbon, we put two hydrogens. In the case of the enamines, we do exactly the same. We still put a carbon nitrogen. We break this bond, and what we put is a double bond oxygen, removing this double bond to form the ketone, and the nitrogen carbon, we put the amine with one hydrogen. Okay? We go to exercise number 2. In the exercise number 2, we have this compound. And we treat this with HCl pH 5. And what we get is this compound here. Plus water. which is the mechanism? Well, if we are in acid media, the first thing that we will do will be the protonation of the carbonyl group to generate this intermediate. Why we are doing this? Why we are doing this? Because we want to increase the electrophilia of this atom, of this carbon. We are increasing the electrophilia of this carbon. Now, this amine will be able to attack with the pair of electrons of the nitrogen intramolecularly. The aldehyde to form this intermediate. Remember that the nitrogen attacks the carbonyl group, and then the pair of electrons that are forming the carbon-oxygen double bond are going to the oxygen. When we have this, basically what we do is we remove one hydrogen to form the hemiaminal. Now, in order to do the imine, all that we need to do is to protonate the alcohol. Why we protonate the alcohol? We protonate the alcohol in order to make the OH a good leaving group. Remember for lessons 1 and 2, sorry, it's a cat, that the OH is a very bad leaving group. In order to, we protonate the OH, and we are making this a very good leaving group. That means that we generate this compound, and now the leaving group is departing, and we get this carbocation, okay, that after elimination of the hydrogen, we get the imine and the water that we lost in the last step. Okay? This is the mechanism to generate the imine. The last exercise tells us that we consider this reaction. We have HCl, we add ammonia, and what we get is an acid-base reaction. Okay, and they tell us that the pKa of the HCl is equal to -6, while the pKa of the quaternarium ammonium is equal to 9. From this, the question is, which is more acid, HCl or diminium? Well, the answer is quite easy, because we know when lower is the pK, higher is acidity. That means HCl will be the more acidic. Okay? Second question, which is more basic, ammonia or chloride? Well, here we have to check the pK of the conjugate acid. In this case, the pK of the ammonium and the pK of HCl. We know that when higher is pK of conjugate acid, higher is the basicity. That means that NH3 will be the more basic. And now they tell us that we have to calculate the equilibrium constant for the reaction. Okay? Well, how we can do it? We know that the constant of equilibrium of the reaction will be the multiplication of the concentration of the products divided by the multiplication of the concentration of the starting materials. Okay? On the other hand, we know that if the pK of HCl is -6, means Ka of HCl is equal to the concentration of the products divided by the concentration of the starting materials. Okay, remember that the Ka of the HCl is this reaction, is the deproportionation of the HCl. And the pK of NH3, that is the NH4, of the ammonium, is exactly the same. This is the Ka of NH4. Okay, the Ka of NH4 is equal to NH3 multiplied by protons divided by NH4. Then the only that I need to do now is I multiply up and down for the concentration of protons. Basically, I am not doing anything. I am only multiplying by 1. And now all of this is exactly this. That means that I can transform this for Ka. That means the constant of equilibrium will be because I substitute all of this for this formula. But now I can substitute this for for this Ka. The only that is inverted. That means that the constants of equilibrium will be Ka of HCl divided by Ka of NH4. Yeah. If I know that the pK is equal to minus logarithm of the Ka, means that the equilibrium constant will be the constant, the Ka of the HCl divided by the Ka of NH4 is equal to minus logarithm 10 elevated to 6 divided by 10 at minus 9. Okay? That means that the equilibrium constant will be 10 at 15. And this will be the result. That means when we have this reaction, the equilibrium will be totally shifted to the products because the equilibrium constant is 10 at minus 15. Okay, please try to check. The most difficult probably is the substitution of these parts of the equation by Ka of the hydrochloric acid and Ka of the ammonium. Okay, but check it and you will have to get the same result that I get there. Okay, that's all. Thank you for your attention and see you soon in the exercise for lecture 5.